Hello everyone. This is the last section of Chapter 5, Chemical Quantities and Reactions, and this is 5.8, Energy in Chemical Reactions. We've been talking about how these reactions look on paper and mathematically, and so let's look at it now on kind of what the molecules are doing. There are three conditions in order for a reaction to occur. Number one, they have to collide with each other, that is, they have to bump into each other. And when they bump into each other, they have to have the right orientation. That is, they have to hit just at the right angle so that they will align and the bonds can form, okay, or break, depending on what they're doing. And then finally, the collision must provide something called the energy of activation. So this reaction, whatever it is, has to be activated in some way through energy. And so there's two basic types of reactions as far as energy goes. The first is called an endothermic reaction. And the endothermic reaction is when heat is released. Okay, something gets hot. The energy of the products in this particular type of reaction is less than the energy of the reactants. And so heat or energy is a product, and so when it's an exothermic, the energy is on the product side. Okay, and so heat is released. This is when things, if you react them and they get hot, then this was an exothermic reaction. Notice they have to overcome an energy of activation, and then their final energy will be less than what they started with. In an endothermic reaction, heat is going to be put into something, or it's going to be absorbed by something. And in this one, the energy of the products is higher than the energy of the reactants. And so you have to, there's so much activation energy required that you have to add extra energy. So it's not going to just happen on its own. And so heat is a reactant in this case, all right? And so in an endothermic reaction, you're going to add energy or heat, and so it'll be on the left-hand side of the arrow in your chemical equation. So let's look at these. You should be able to knock these out pretty quickly, so if you want to put me on pause and come back, we need to identify these as either exothermic or endothermic. Okay, remember the definition for endothermic, exothermic. If it's exothermic, okay, heat's going to be given off. And if it's endothermic, heat's going to be put in, okay, or energy. So in this particular reaction, is heat given off or is it put in? Well, it's a product, which means it's going to be given off. So that one would be exothermic. In the second one, in B, did we put energy in or did we release energy? I believe that we had to add energy because it's on the reactant side. So that one must be endothermic. And then finally, the last one, instead of energy, and this stands for kilocalories, by the way, which is a unit of energy, we're giving off as heat, and heat is a form of energy. And so in this case, what? We have given off heat, and so that is an exo. And if you want to think about that in exo, energy exits. I keep hitting my button today. And in endo, energy enters. Okay? So it exits, so it's a product. It enters, so it's a reactant. And we got those right. Now, when we have a reaction going on, sometimes it's very important as to how fast the reaction is going. In the human body, for example, we have enzymes and things like that that really speed up the rate of the reaction because we have so many millions of reactions going on at the same time. And so the reaction rate or rate of reaction is the speed at which the reactant is used up while it is also the speed at which the product forms. Okay, so we're using up the reactant on the left-hand side to produce these products on the right-hand side of the arrow. If you increase the temperature, then the molecules are going to bounce around a lot faster. They're going to collide more because they're moving more, and so they are going to provide some of that energy of activation. So if you increase temperature, you're going to increase the rate. And so I think about this like if I'm standing on a hot sidewalk and barefooted, and if it's super hot and I've got to walk across or whatever, I'm going to move very quickly because it's burning my feet. And so as opposed to if it was just a nice, moderate day and I could just stroll along, if it's super hot, it's burning my feet, I am going to move as fast as I can. So it's the same thing with molecules. When you ramp up the temperature, they're going to move a lot faster too. Also, the thing that can increase the rate of reaction is if you increase the concentration of the reactants. If I have some glucose and I add more glucose, that can also increase the rate of reaction. The third thing that can increase the rate of reaction is adding something called a catalyst. Okay, a catalyst is something like an enzyme in the human body, but it can be other things. And so it increases the rate of reaction by lowering the energy of activation, and it is not used up. So remember me talking about how in order for this reaction to go, it has to have a certain amount of energy to overcome this activation. Well, what a catalyst does is it literally lowers that, makes that hill shorter, okay, if you will. So instead of this much energy, you only have this much energy to overcome. And so that makes it a lot easier to make those products. And so, and the catalyst, when it's done, it's regenerated, and so it's ready to catalyze that reaction again. So the catalyst increases the rate by lowering the energy of activation, and then it's recycled. It's not used up, and so then it comes back and is ready to do the same thing all over again. And so it increases over and over and over. So things that increase the reaction rate, the reactant concentration. If you have more molecules, you can have more collisions. Increase the temperature. If you have an increase in temperature, they're going to move faster, and so it gives you more collisions. And if you add a catalyst, it's going to take less energy to have to overcome in order for that to happen. And so those are the three factors that increase the rate of reaction. So in this learning check, let's say if it will increase the rate, decrease the rate, or have no effect. If you increase the temperature, will that increase, decrease, or have no effect? It will increase. Remove some of the reactants. Now we said before if we add reactants, it's going to do what? Increase. What if we remove some of the reactants? That puts less molecules in there to react, and so that will probably give us a decrease in rate. If we add a catalyst, we increase because of lowering the energy of activation. What if we place the flask in ice? What have we done to the temperature? We have decreased the temperature, and if we do that, we're going to slow those molecules down. I know I'm a lot slower when it's cold out than I am when it's warm out. So molecules are the same way. When they get cold, they slow down, and which decreases that rate of reaction. And then increasing the concentration of one of the reactants is going to what? Increase that rate. All right, so it looks like we were correct, and so we know which effects that's going to have. And this is a specific reaction that they want you to look at and decide if doing these things down here, A, B, C, and D, are going to affect this reaction by raising the temperature, adding oxygen, adding a catalyst, or lowering. So what effect do you think that it would have? Increase, decrease, or no change? Raising the temperature, increase. Adding oxygen, is oxygen a reactant? It is, so that would increase. Adding a catalyst is going to decrease the activation energy, so that will increase. And what about lowering the temperature? The opposite of raising the temperature, it will lower the reaction rate. Very good. And that is it for this chapter. So we've learned about endothermic and exothermic reactions and the three things that can increase a reaction rate, and also the opposite of those, which can decrease the reaction rate. All right, that's the end of chapter 5.